What if you have a steady state inductor circuit with a current I E by R? But this inductor has a core, that is this core actually increases its inductance from L to 4L, that is without. Now when you put the core inside this, the inductance changes to 4L, but in this circuit the core is already inside. Now the question is, if you take the core out, then what will happen? Will the current change, or will what will happen basically? Now from the basic theory of inductor, you might say that current won't abruptly change, so the current will remain E by R for one instance, and then it will slowly start to change. Either it will decrease or increase, that we will have to find out, but the current will remain same. That is actually wrong, because what actually happens in an inductor is that when you there is a flux B. When you actually increase this B, you're actually trying to increase the flux, and the inductor doesn't want that. The inductor prevents change in flux. That is the most basic operation an inductor does. But since it is preventing the change of flux, how will it even do it? In which way can it even prevent the change of flux? And the answer is by inducing a reverse current. This current will induce a magnetic field in this direction, thus reducing the flux. So the primary task of an inductor is no change in in flux. It wants to keep the flux constant. In this case, you are trying to increase the flux, so its only way to decrease the flux is to induce a current in this direction. If you were to decrease the flux, then its only way to keep the flux constant would be in this direction. Now in this question, what happens is that we have to use flux conservation, that is phi 1 equals to phi 2. Phi 1 is the flux just before we take the magnetic core out, and flux or phi 2 is the flux just after we take the core out. And the flux 1 is L I1, and the flux 2 is L by, this should be 4L, L into I2. Now we can just cut this and we get I2 is 4 times I1, and I1 was E by R. Now this is very hard to believe that the current became 4 times. That is, this current which was going through increased by 4 times. The inductor, we knew that didn't let the current change abruptly. On its own changed this current to 4I. How come? Because that is the only way it can not change the flux. Because see, if it did not change, what would happen? So phi 1 would be L 4L into I. I is E by 4, or let's write that I naught. And if it did not change, then phi 2 would become L into I naught. And this is so bad because the flux is changing, and its primary motive is no change in flux. And how does it do that? By no change in flux, it does through manipulating the current. Right now, the only method for it to increase the flux, at first it was like this, and now it is this. This is not good. he wants to add a lot of flux more, and that means he will act like a cell and induce a forward current. But the question is, shouldn't that take time? Inducing a current in an LR circuit, especially if it were an L circuit only, then obviously it shouldn't take time, but it's an LR circuit. So it obviously should take time, but then again, this part I really can't explain, but that's actually what happens. To keep the flux constant, the inductor abruptly changes the current to 4I to keep the flux constant, and that is how you can find the I, final I. This was a question from BM Sharma, and it was question 26, I guess. You can check it out.